Hi, my name is Yusuf, and today I'm going to show you uh, the new platform for modeling Kirchhoff's equation in pharmacokinetics. These based on new theories that have been developed by Dr. Benet. So let's get started. You can obviously see I have a lot of options for multiple compartments here. So for example, I'm interested in a liver compartment, so I can pick one here. I can adjust the setting, like I can change the hepatic flow. So for example, I want to reduce hepatic blood flow. I want to add some basically transporter effects. So for example, there's a transporter effect for this drug. Maybe increase transporter effect, like let's say 5 liter per hour or something like that. And there's maybe a little bit of efflux, which is like if you know that it exists, you can add it maybe and just calculate basically the difference. So yeah, pretty straightforward. You can see also there's other options for other compartments. So for example, kidney doesn't have obviously hepatic blood flow, but you can use glomerulus filtration rate. You can change it, you can decrease it. Say for example, somebody has a problem with his kidney, so you want to decrease. You can connect it to other compartments. You can add a GI tract here or a systemic. Let's just say I was wanna say like there is no blood here. I just wanna add connected the gut to the liver and to the kidneys. And since the two processes are basically parallel, I need to change this to parallel so actually not to actually be able to add the clearance together instead of sequencing as according to Kirchhoff equation. So one also thing you can do is basically you can there's a template for whole systems. So this is like basically a typical oral dose, like a one compartment oral dose, and you can see it just goes into the liver. So you have like an oral, like a tablet in the gut, and it goes to the liver, etc. I just the reason there's two livers here is basically because it's this is where it just get metabolized, and this is like a clearance one. So but there is actually still like a clearance here. You can see there is a clearance here actually, so it goes out of the system, but some of it just get back into the system, and but again it goes back again to the liver and just get cleared out. So yeah, this is basically how it works, and you can how to use it. So one cool feature is actually, I mean, the whole point of Kirchhoff equation is basically that. Um, so obviously, if you make any changes here, you can see the effect. So say for example, I change the clearance. Let me see if I change the clearance here, and if I add it like 2, you can see that you see have dramatic clearance because there is a decreased absorption, and according to Kirchhoff equation, like if you have actually decreased clearance in the absorption or like decreased absorption, basically, it actually you get more AUC because it's like there is less excretion and so on. And yeah, so let's just get back to 500. I just see also what you can do also is you can basically see there's a curve like just plots for you the doses based on time, and also actually if you have like a reduced absorption. So for example, you have like 20 reduced absorption. You can see actually it starts to show you that what is going to be the difference between uh, predicted concentration according to Kirchhoff equation versus the traditional like PK models is. And if you actually decrease it even further, you can see the difference is even bigger. And you can also add multiple doses. So for example, I want to add like maybe 5 doses. Time between them is basically 10 hours, and you can see just start to model that if you want to model like something like steady state or something. One final thing is basically also you can add multiple compartments. You can, if you want to add something like peripheral compartment or something like that, you can also change it. It's going to affect basically the uh, how the model is and pharmacokinetics. So pretty cool website. We're just testing it. I hope you can try it and just give us your feedback. Thank you.